that sour tang of a lemon? Or the kind of bitter taste if you accidentally get soap in your mouth? Well, our world is secretly run by a hidden chemical showdown. Today, we're going to play detective and uncover the secrets of acids and bases to solve some very common mysteries. Have you ever wondered about these little things? That really uncomfortable feeling after a big meal? Or what about when a curry stain on a white shirt suddenly turns reddish-brown when you try to scrub it with soap? These are not just random accidents, people. They're clues. Clues in a chemical investigation that we are about to crack wide open. All right, so the main suspects behind all these mysteries are two chemical families, and they're hiding in plain sight. They're called acids and bases. And trust me, you encounter them every single day, probably without even thinking about it. So, what are we looking for? What are their fingerprints? Well, acids, like the stuff in lemon juice or vinegar, usually taste sour. Bases, on the other hand, tend to be bitter and feel kind of slippery, just like soap. But the classic way to tell them apart is with a little strip of litmus paper. It's simple. Acids turn blue litmus red, and bases turn red litmus blue. Easy, right? Now, tasting unknown chemicals to see if they're sour or bitter? Yeah, that is a terrible idea, so please don't do that. Chemists have much safer and frankly cooler ways to identify these culprits. They use special tools for the job called indicators. An indicator is basically a chemical detective. Its whole job is to reveal the secret identity of a substance, and it does that by changing color or even its smell the second it comes into contact with an acid or a base. So we've already met our friend litmus, but other chemical detectives have their own unique signals. Take phenolphthalein, for example. It's totally colorless in an acid, but put it in a base, and poof, it turns this brilliant pink. Then there's methyl orange, which goes from red to yellow. Each indicator has its own special color code. Okay, changing color is pretty cool, I'll give you that. But what if the clues weren't something you could see? What if you had to use your sense of smell to solve the case? Yep, this is where olfactory indicators come into play. These are substances whose actual smell changes depending on if they're in an acid or a base. And the crazy part is, we're talking about things you might have in your kitchen right now, like onions, vanilla, or even clove oil. They can all act as these unique smell-based detectives. So we know what they are, and we know how to identify them. Now for the really exciting part. What happens when acids and bases actually meet other substances? This, my friends, is where the action really begins. Let's kick things off with a classic showdown, an acid versus a metal. Just imagine dropping a few pieces of zinc metal into some dilute sulfuric acid. Almost immediately, things start happening. You see all this fizzing going on in the test tube. So what's actually going on here? Well, the zinc is reacting with the acid, and all those bubbles you see, that's a gas being created. And here's the cool part. If you collect that gas and bring a flame near it, you get this really distinctive pop sound. That pop is the telltale sign of hydrogen gas. It's the smoking gun. And this isn't just a one-off trick. It's a fundamental rule in chemistry. Whenever an acid reacts with a metal, you are always going to get two things, a salt and that flammable hydrogen gas. Every time. Oh, and that's not all. Acids also have, let's say, dramatic reaction with things like chalk or limestone. In this case, instead of hydrogen, you get a whole lot of fizzing that releases carbon dioxide. Yep, the exact same gas that makes your soda bubbly. We've seen acids behaving in some very similar ways, right? This suggests they must all share a secret ingredient, some common feature that gives them their acidic superpowers. So let's figure out what it is. Just think about it for a second. All the different acids we've talked about generate hydrogen gas when they react with metals. That seems like a pretty massive clue, doesn't it? Hydrogen seems to be the common link here. But is that the whole story? Okay, this next experiment gives us the final piece of the puzzle. See, if you try to pass electricity through a solution, the bulb will only light up if there are charged particles, called ions, to carry the current. And look, in an acid solution, that bulb glows brightly. This tells us for sure that acids must be releasing charged ions when they dissolve in water. And there it is, the secret ingredient. The charged particle that all acids release in water is the hydrogen ion, or H+. That one tiny little ion is responsible for everything we think of as acidic. And on the flip side, bases release a negatively charged hydroxide ion, OH-, and that is the source of all of their powers. We now have all the pieces. We know what acids and bases are, we know how to spot them, and we know what makes them tick.
It is time to put this knowledge to use and finally solve those mysteries from the beginning. This is the ultimate chemical showdown. When an acid and a base meet, they don't just react, they neutralize each other. The H plus from the acid and the OH minus from the base get together to form simple, harmless water, leaving a salt behind. They literally just cancel each other out. So let's circle all the way back to that first clue, that painful indigestion after a big meal. How does this chemistry of neutralization solve that particular mystery?
It's actually beautifully simple. Indigestion is just too much acid in your stomach. An antacid tablet contains a mild base. So when you take it, that base gets to work and neutralizes all that excess stomach acid. And the result? The pain goes away. A real-life neutralization reaction solving a real-life problem.
And that right there is the key takeaway from our entire investigation. This power to neutralize, this ability for acids and bases to cancel each other out, it's not just some neat trick in a chemistry lab. It's a fundamental principle we use every single day, often without even realizing it. And what about that curry stain? Well, turmeric, the spice that makes curry yellow, is a natural indicator. So the soak, which is a base, causes it to turn that reddish-brown color. That's chemistry at work right in your laundry basket. From cooking to cleaning to gardening, this science is absolutely everywhere. So now that you're in on the secret, where are you going to spot it next?